By the way, I had to restart my computer this morning because it froze on me. So if that happens, that's just wait a few minutes at home, okay? And so we're going to do a regression. Once you have your table, it's just like the other ones. You perform a regression, and you have to work at looking for it, finding the curve on your graph. That's going to be the problem here. Remember, anytime you put stuff into L1 and L2, you want to have plot 1 turned on, okay? Because you're using quad reg. If you're not using quad reg, turn it off, okay? So when are you not using quad reg? When the equation is already provided. Okay, now you're able to answer all kinds of questions. A graph, I can ask you for the domain and range, and so forth. Okay, so that was Friday. And then I asked you to write this down. I don't know. I also asked you to do in the handout, there was a homework sheet that I gave you, which would only have been a PDF online. I don't think I gave you the printed version of that, and for you to try these 4 questions, okay? That's type 1 question. Now, we're gonna finish the notes here. So this is the question that we're gonna attempt today. We're gonna answer this and see how this goes. So write it down if you haven't done so already. Okay, so go ahead and write this down. And I will start answering it in a bit. I'm going to turn off the front lights because my calculator. There's always a delay on my calculator if I don't. Okay. So naturally, you can't do anything until you have an equation, right? So you're going to have to come up with an equation. And the way we do that is to come up with points. You got to come up with a certain number of points. And 3 is the minimum. If I give you more than 3, though, like a type 0, you go ahead and type in all the values that you're provided with. So we're enclosing a rectangular area. There is no other detail given. You're not splitting it up. It's just literally a rectangular area. It's as simple as it possibly gets. So we're going to start with a simple scenario here, okay? So the first thing I would do is make a diagram of the situation, right? The longer sides are usually called length, and the other sides are width, okay? So you're essentially fencing in this area, okay? Now there's a couple things here. The area, because we're talking about fencing, the perimeter of this enclosure would be found by going 2 times length plus 2 times the width. Okay? Just going to check something here. There, my bad. And we know that the perimeter, right, is the fencing available. Okay, so we know that the perimeter is this in terms of the equation of this shape that you're enclosing, but we also know that perimeter is the fencing available, right? So in this case, we have 600 meters. We have 600 meters available. Okay, so we basically will replace the P in the first equation here with 600. Okay, this is your starting point. You need that number in there. So therefore, 600, that fencing has to be spread out over 2 lengths and 2 widths. Right? So I'm basically saying P is this, P is also that, therefore those two have to be equal, right? These two have to be equal. The question mentions that you have 600 meters of fencing available. So essentially, the 600 meters is going to be spread out around this enclosure. So you're saying that P, the perimeter, right, can be a maximum of 600 meters. So I'm basically plugging this, the fencing available, into P here. And I rewrite this equation now with 600 in place for P. Does that make sense? Yeah. And if you look at the steps that I gave you, I'm going to look at the steps so I kind of keep in line with them. It says draw out the scenario. We've done that. Step 2, rewrite the equation of the perimeter so that L is isolated. So that's what we're going to do now. We want to isolate L. Okay? So we're going to do the work here. Okay? So 600 is equal to 2L plus 2W. I'm going to rewrite it one more time. I'm going to subtract 2W from both sides. That's essentially what's happening here. So I'm going to go minus 2W minus 2W here. So you end up with 600 minus 2W on this side, and on the other side it's 2L. That should be pretty straightforward so far. And then I'm going to divide both sides by 2, right? Because whatever is in front of L, I want to get rid of it, and the 2 is multiplying, so I have to divide. That cancels out. Therefore, length, I'm just going to have the length on the side here, is 600 minus 2W divided by 2. So later on, I'm just going to tell you, bring the 2W over subtracting, and then divide both sides by 2L. By 2, sorry, not 2L. And so now you have length in terms of width. Okay, so I'm going to kind of like just bubble this thing because it's very important in your work that I see this somewhere to give you marks. Okay, so here we go. This may or may not be given to you, okay? It depends on the situation. If it's not there, you have to come up with it. But it all starts with the perimeter. What does your shape look like? Right? What is involved? And then you plug in the fencing available in for P and follow the same steps. But this will look different from question to question. It will not be the same. Okay? Question, could you have isolated for W instead of L? Yes. But I will always stick with L, and if you want to get the same answer, like you will still be correct, but if you want everything to be the same when you check your work, I would suggest you isolate L. So anyway, so this is our table, length, width, area. Leave a little bit more room for L for now, W, sorry, for now. Leave a bit more room for W than you used to. Okay. So in this particular instance, right, you can choose, and whatever variable is on the right, this is called the independent variable. Okay. So we're going to call that independent in this case. Meaning you get to pick values for it. It's your X in a sense. So you come to the independent variable, and what I do is I try 10, then I will try 20, and then I will try 30. These are random. I will show you that it doesn't really matter what you pick. Right? You choose values. You could do 1, 2, 3, but I'll show you later on 1, 2, 3 is not the best. So I strategically stick with 10, 20, 30, and it works out. Okay, so now that you have width, we will use this equation every single time to come up with the length. So if the width is 10, we're going to figure out what length is. Okay, so in this case, length would be 600. I'm going to start a bit further to the left, actually. It's going to be 600 minus, right, 2W, and W happens to be 10 in that case. So you go and do that, and you divide that by 2. And what do you get there? So I'll show you how I do that. 600 minus 2 times 10 is just 20, right? Divided by 2. And so it's 290 for the first one. So we're going to plug in 290 here. Sorry, I know I should have given myself a bit more room there. I repeat the procedure. So maybe what I will do is to keep the rows straight. I'm going to put the 20 here and the 30 here, okay, just to have a bit more room. So essentially 3 rows like this. So for this one, length is 600 minus 2 times what? What is W? It is 20 in this case. And you divide that by 2. The biggest mistake is that I find is that folks don't divide by whatever it's supposed to be divided by. So this would be 600 minus 40, right? And you divide that by 2, and you get 280. Okay, so this is supposed to be 280. Then you have 600 minus 2 times 30. So you can see how it's very important to get this right. So that'd be 600 minus 60, right, on my calculator, divided by 2, that's 270. I will tell you something that you can check for. There will be a pattern from one to the next, and it should be consistent. Watch. This was 290, now it's 280, 270, so this should consistently be going down by the same amount. This is also consistent, right? These are, who got these numbers? We picked them. You could have picked 100, 200, 300. You could have picked 25, 35, 45. It doesn't matter. But if you are consistent with these, then you will also see a consistent change here. That's why I like to pick 10, 20, 30, okay? So area, remember, is length times width, always. So we're going to find out the area for the first one here, which would be 290 times 10. And then here would be 280 times 20. And then it would be 270 times 30. And that is your, now you have your table. So now A is asking us, where do I have that written here? Part of this equation of length versus area, right? Yeah. So for A, we're gonna put the length goes into L1 and the area goes into L2. And then we're gonna go stat calc quadreg and come up with the equation. So let's go ahead and type that in, okay? So stat, enter, clear whatever is in there. Okay, so it's 290, 280, 270, and L2 is 290 times 10, 280 times 20, 270 times 30. You may or may not want to enter the actual values here. I'm fine with you just leaving it as is. You don't have to actually write down what the area would compute to. But now let's perform the regression. And I haven't done a regression in a little while here, so I'm just going to type everything again. It's probably a good habit to redo it every once in a while. And you get negative x squared, right? Negative 1x squared plus 300x. And that's it. What about this one here, Mr. Dirksen? It's e to the negative 8. That's technically 0. Neglect. Okay, omit this one. And remember, this equation would relate length and area. Every single point, if you were to graph this guy, would give you length and area. Before we go to B, I'm going to ask you to graph this, like just on the screen, on your calculator. So I'm going to go to y equals, ensure that everything is off, but I'm going to make sure plot 1 is turned on, right? So this is already the equation that it put in there. That's the one you're using. You're not going to write it over it because you don't like it, right? This is the one you use. That quadreg pasted in there. We're going to go zoom 9. And of course, you're only going to see a little stretch of it. It looks like a straight line, except for you're going to go window, -5 for x-min, -5 for y-min. That's the first step. You hit graph again, because that makes sure you see the origin, and then we'll just increase whatever we need to. So my y max needs to be increased quite a bit, and the x max also a little bit. So window, x max, I'm going to go 400, and y max, I'm going to go 20,000. Just, oh, it's still not enough, so I guess I have to go 40,000. And there it is. As soon as you see the arc, right, that arch there, then you're fine. And you see the 3 points that you have created that allowed the quadreg regression to make the whole curve. Okay, you've only found 3. Okay, let me demonstrate. I need you to understand what's happening here. I just need you to understand. So let's say, okay, for instance, you picked 5 for your width, okay? Or let's go higher. You felt like making this 150. This is just, I will make a note later that this is not necessary, okay? But let's say we were going to come up with a 4th point. If this is 150, then this would be 600 minus 2 times 150 over 2. If we do a little bit of mental math, 600, 2 times 150 is 300. So 600 minus 300 is 300, divided by 2 is 150. Right? So then this column here would be 150 times 150. Okay? So if I were to go to stat, edit, and add that point, 150, and this is 150 times 150, and if I were to graph this, see this point right here? It was added to your graph, right? It's still on the graph, so it doesn't matter what you pick for W, it will still be on the curve. Okay, so you don't have to use 10, 20, 30. You can use, I don't like 1, 2, 3 because then all the points are going to be like right here somewhere. But, 10, 20, 30 seems to do pretty well for most questions. Okay, that's why I use it. Okay, this is optional. Right? This point right here is optional. By that I mean this whole thing. Okay, make sure you know that. It's not just like, oh, you don't have to do this column, right? This whole thing. That's optional. Okay, so there it is. B. We're gonna put, that one is asking us for the greatest area you could fence in. The greatest area would be the top, right? If you think of area being along the y-axis, it would be right at the top here. It seems like I already found it by coincidence, okay? So but the top is what we're after. So don't estimate, you're gonna find the max, okay? So we're gonna go ahead and go second trace 4. And I think it's gonna be 150. So it just happens to be it. Yeah, it is that. So it's 150, 22,500. That's the coordinates of it, but which one of these two represents area? It's this one here. So max area is 22,500 what? We are talking area, so it's square meters. That's the maximum area that you could enclose with this, with the amount of fencing and the shape that you're fencing in. Okay. C is asking us for the dimensions. Okay. I'll just scroll up a bit here. The dimensions that would result in the maximum area. Well, first of all, maximum area is 22,500. We know that, right? Comma, the length at this point is what? We know that the length is 150. We can use area is equal to length times width to determine the width, which you already know. I picked the wrong point. I shouldn't have picked 150 because then you know already, right, what's going to happen. But So, right, so area is length times width. We know that the area is 22,500. We know that the length at this point is 150. We don't know what the width is yet. Let's pretend we don't know, okay? You would divide both sides by 150. Get rid of this. And when you go this divided by 150, you do get 150 meters. So dimensions of 150 meters by 150 meters will result in the maximum area. So dimensions, we're talking about length and width, okay? They want to know the length and the width that you would have to use to get that maximum area. And I quite frankly don't care. Like, let's say these numbers, most of the time these numbers will be different. If you just tell me if you just mention those two numbers, that's all I need to know, right? Let's say it was like 30 by 50. You just say like dimensions of 30 by 50 will do the trick, okay? But I use the formula, use what you know, that the area is always length times width, always, always, always. So if you know the area and you know the width, you can find the length. And the other way around, if you know the area and you know the width, you can find the length, right? That's how it works every time. So when you get a question like this, yes, you're going to have to use second trace and find the max, but once you have one of them, you can find the other one. Okay, D. D is the asking for domain and range. So if we just have a visual here, we know that it starts here and goes like that, right? And we know that under these circumstances, whatever I ask you to graph, that's the one I want you to use. So this would be length and area. So for my domain, I would need this, right? And for my range, I would need this. This is for domain, and this will be used for the range, okay? I already know what this is, but for the domain, I don't know yet. I know it's 0 to a certain number. So let's go ahead and find the X-intercept. Y2 is equal to 0. That's close enough. You're closer to this one than the other one. So it's 300 is the maximum here, the X-intercept. This one is 150, 22,500, right? So the 300 goes for domain, and my range goes from 0 to 22,500. Okay. E, you're asked to graph it now. Now you have to area and square meters, okay? Label and units. I need to account for 300. That's not too bad, right? I'm just gonna conveniently go up by 100. Here I'm gonna go to 25,000. So 5, 10, 15, 20, 25. So, and I will go to 30,000 actually. Okay. I know that at 150, I'm at the highest point of 2250, which is between 20,000 and 25,000. And I land here And I'm also at 0, 0 because my y-intercept is 0, 0. It's like the initial. There it is. Isn't it fun to learn about this on a Monday? I know it's probably not everybody's cup of tea. I have another one that is we're gonna add a twist to it. Okay, write this down. There's nobody writing a test right now, Mark. No, October 19th. That'll be everybody. Okay. We will proceed. Notice that now you have 700 meters of fencing available. Slightly different. And we're building an enclosure next to the barn. Okay, so let's draw this thing. So if this enclosure is going to be split in two, right? And on this side, there's a barn here. So we kind of just say this is the barn, right? So there's essentially no fencing required on that side to save on materials, right? To save on fencing, which allows you to actually make a bigger enclosure because you're not spending fencing, right? You're not using fencing on this side. No fence. Okay. Okay, so we have the length of this thing, which is end to end, and we have this width right here. We've got this width right here, and we've got another width right here. That's what's happening here. Okay, so it's always going to be a rectangular area of some sort, but like how many L's and W's are in the mix is going to differ. Okay, that's basically what we come down to. So perimeter in this case, just start by looking at this, would be length plus 3W. Okay, we have 700 meters, so it actually, oops, turns out to be this. We bring the 3W over to the other side, subtracting, and it's just that. Or length is 700 minus 3W. Isn't that pretty, that makes it pretty easy, right? I'm going to use this one. There's nothing we need to divide both sides by because length happens to only have a coefficient of 1. So this is what I'm using for my table. That's where a lot of students get stuck. They're like, how do I even get started? It all starts here and there, and you have to have length in terms of W. If you don't have that, you're not going to be able to get started. Now let's make our chart, right? So length, width, and area. I actually lied to you earlier, right? To make the width wider, you make the length wider, if you can. Okay? This will be 10, 20, 30. I may change that from time to time. And then so the length here would be 700 minus 3, whatever the width is in this circumstance, which is 10. And this is actually fairly simple to do. It's just 670, right? And then you do that same thing again every time. Right? So that's 60. So that'd be 640. And here you have 700 minus 3 times 30. And that'd be 610. Notice that we're going down by 30 every time. That's good. This is going up by 10 every time. That is good. Okay. Just a check, right? And then so area would be 670 times 10, 640 times 20, 610. After this, once you've determined that and you've calculated this, it's exactly the same as type all the other types, right? You just plug it into. So I guess I don't need that much clearance here. So there it is. And these ones you pick. I will tell you this. Sometimes students actually take me up on that. They take me up on the you pick, right? And they pick some weird numbers. It's kind of neat, right? Because I see that you were listening. But then when you plug it in here, you end up with a negative. For some reason, since you picked a weird number, you keep that negative. As long as you did the work right, it will work, okay? You keep that negative, whatever you get here, you use it, or else it will not work, okay? Some students think it can't be right because they got a negative here. So let's say they pick 1,000, 1,000, 2,000, 3,000. Just think about it. 700 minus 3 times 1,000, this would be a negative number. That's okay. All right, there's nothing wrong with it. All right, it'll just be a weird, like your graph will be way off, so your window will be off, so you're gonna have to do some work on that. So 10, 20, 30 works. So I would say keep it that way. All right, it's 3 o'clock, so I want to make it through this, okay? This one, you want to practice, okay? I can tell you that. We want to relate length and area, so we'll put length into L1, area goes into L2, and then we're going to tell the audience what we're going to do, and here we go, okay? So stat enter. Let me just bring this up, clear, clear. And watch as you're typing in, make sure you get it exactly the way it's supposed to be. I'm going to go back to my home screen, just go up and look for quadric that I just did a little while ago. And it's negative 0.33 x squared plus 233.33 x, and c is 0, which is going to be the case pretty much every time. So that is the, and I will just make a note that we length and area. If I were to use this equation in my my y1 and I find a point, the first one refers to length, the second number refers to area. This is the neat thing, that both of them, the area will correspond, right? The area will be the same for the finding the maximum area for both will be the same, okay? It's not like it's going to contradict. So B, width versus area, so we put the width into L1, area into L2, stat calc quadreg. So all you need to do in this case is change this to 10, 20, and 30, right? Because the area is going to be the same. Okay. I'm going to go ahead and perform another regression. And it's negative 3x squared plus 700x. And yes, it is different, right? It looks different. These two do look different, okay? So here it's width, area. Every single point that you were to find here would be width, area. You don't have to do this when you give me your answers. I just want to make sure you understand that that's what's happening. C, it's going to be a little like it's a mix mash here, okay? Sorry about that. Watch what C is saying. Dimensions that would result in maximum area being enclosed. So because of that maximum area, we're going to have to find our vertex. Okay? You want to find the vertex. So we're going to go ahead and find it. My graph actually just happens to almost work out based on the last window. I'm going to move my calculator soon, okay? I just increased my Y max a little bit. And let's go ahead and find the vertex. We're not seeing it here. Hold on. So it's 116.67, 40,833.33. Now, what is this number again? We are using this equation to what we just found, all right? So this first number represents our width. Okay, so the width is 116.67 meters. So that would be the one dimension. What about the length? Length, we will use the area divided by the width. Because remember, area is length times width, so we just use that formula, plug in, and find the rest. That's basically 349.99 meters. If you actually just do this, I will be fine. Length and width are circled. Dimensions of 116.67 meters by 349.99 meters will maximize area. You're finding the best possible scenario how to use your fencing to create the biggest enclosure. Oops, sorry. Move this up a bit. I'm going to give you a visual here. So let's say this is the enclosure we were just talking about. And we split that in half, right? The assumption is that they're going to be exactly the same though. What you just found was that length, this length right here is 349.99, and that every single piece here is 116, 116.67, 116.67, 116.67. That's what you're finding, right? Like these would be the dimensions of the fencing for all those sides there. You just want the one enclosure, this one right here. So just, oh my goodness, I'm not really good at making notes in tight spaces, so just one enclosure. I would have to split this in half. You split this in half because then you get, right, each one of these sides. So length would be 349.99 divided by 2, which is 174 something. 174, basically 175 actually, which is 175 meters. And the width is just what it is, okay? There's no news there. So the width is that, the length is that. That's for one enclosure. So you would say one enclosure is 175 by 116.67. Very rare, this question, I will tell you that because I'm more focused on you being able to find the equation, the max, and the dimensions that will maximize the area, not so much the dimensions of the actual enclosure, but the homework will have some of that, so I want you to be able to answer it. Because the length that you find here, right? Because remember our original diagram calls this whole thing length, right? And if you just want, so this is the big enclosure that you're making, and it just wants one of these sections. So you have to split the 349.99 in half to get just one here. So the one subdivision, so to speak, would have to be 175 by 116.67. Does that make sense? Yeah. Where are we at? Domain and range of width and area. So, right, there could be a domain and range for the length and area. Now we're doing width and area because this is the last thing that we did. So there's a domain on the width and on the area. So let's go ahead and do that. I'm going to do it on the back side. Was it E? Yeah. So for domain, it's going to be this to something. For range, I already know what it is. It's going to be 0 to, watch here, I'm going to just show you. It's 40,833.33 because that's the maximum area, right? So range talks about area. And I already forgot. It's unbelievable. See it there, 40,833.33. And for the domain, you'd have to find the X-Intercept. So we'll show that. Let's find the X-Intercept quickly. $233.33. Right? You need this to do that. Okay. This you get from your vertex. F, right? Graph? No, F is an interesting one. F is the 35,700 scenario. Sorry, I know some of you are thinking 35,700. I just want to make sure I get that right. It's basically saying if y is equal to 35,700, find x, right? Which in this case is we'll find the width in this case because we're using that's the equation, the second equation, right? So we will let y2 equal to 35,700, and then we're going to find the intersection. Notice that I say dimension or dimensions, right? So there is more than one possibility. So y2 is 35,700. And notice what's going to happen here. You have that area twice. Okay, how's that possible? Well, in the first instance, your length will be shorter than the width, right? So it's that scenario. And then here, right, your width will be shorter than your length, but both dimensions result in the same area. It's kind of like the price per ticket and the tickets sold. If you increase one, the other one will drop and vice versa. Okay, so we're gonna find both of these points. I'll write down the first one because I'm already there. So let me just 158.03, 35,700, and the first one 75.30, 35,700. This is width and area, width and area. So there are two instances. So they want the dimensions for this scenario and the dimensions for this scenario. So this one, I already have the width. Length is always going to be area divided by width, by the way. So it's 35,700 divided by 158.03. And I did it slightly differently last year. So I want to have exactly what you have. This is 225.91 meters and a width of 158.03 meters. So this will be first that second scenario over to the right of the vertex. And this would be length is area divided by width again. And that is 474.10 meters. And the width here would be 75.3. Was the first one right? Was this right here? It seems a little off to 7530. Is that what everybody else got? Yeah, that's what I'm getting. Okay. Checking my work here. 158.03. Yeah, okay. So these are the two scenarios. And think about it this way. If you were to multiply these two numbers, you get the exact same area as if you multiply these two numbers, right? The area is still the same, it's just different dimensions. Okay. F, and then we have G, right? Graph. You love this one. I know you do. Can't wait for the graph. There you go. Here. So what are we graphing again? Okay, we're doing width and area. So it's the equation, the latest one we've done. And it's in meters, square meters. I need 100, 200, 300, that'll do. And what I do to help me is sometimes I split the spaces, the gaps in half, just to help me. And I need to account for 40 something thousand. 10, 20, 30, no. So I'm going to go 10, 20, 30, 40, 50, okay? So this is 20,000, this is 40,000, and let's go 60,000, right? So I'm labeling every other one, but my scale is really 10,000. My vertex was, I just need to check my vertex, folks, okay? When it comes to width, 116.67. This should be 150, so 116 is here. We're in the 40 something thousands. 233 would be right about there. We start at 0, 0. So obviously this window, right, is quite zoomed out, right? But that's okay. Sorry, I'm just. .116 point, is it 83? 67. Sorry, 67. There it is. Intercepts, vertex, equation, label with units, scale, done. Your homework is type 2 worksheet. So this is where homework really is really important for you to be able to do this fast enough. Okay, so I understand some of you are like, yeah, I kind of get it. I would be able to like putter through it somehow. But the problem is on a test, you're going to run out of time if you're going to take all the time in the world. So you got to become really good and really quick at finding everything, graphing it, and knowing what to do, okay? So this is the one, right, that I want you to work on. This is your homework. And I will post the answer keys as well. This one, I know for sure I have a type 1 in there, and yeah. So this reviews actually everything, okay? So there's probably 2 type 2s, and then the rest is a mix of the other types. So you should all have a copy. If you don't have a copy, I have a few extras, right? If you're not sure, if you're here, this is the one, right? I'm pretty sure everybody went through my handouts and everybody has them. Okay, so I'm going to stop recording.